Hello.
Yes,
Hello.
welcome, Dr. Indramani. Welcome. Namaskar. So we are, for another day, we are there.
Namaskar. Namaskar.
All of them can talk. All of the panelists can talk now.
Yes.
We can see all of them turn on the camera. I think, like DDG told first, you can utilize this time before starting. You can see all the faces.
Manjul, you are just stone's throw away from here. So Manjul, hi, because I know that you are just one stone away from here.
Right. No, but I came to office because in home, with children sometimes difficult. So I.
Right. Okay, I see that you are in your office. Okay. Hi Vijay. Hi Parth. Hi Dr. Indramani. Namaste.
Yes, sorry for the interference. I just want to remind all of you that we are live on Facebook. That's
okay.
Continue,
All right.
please.
Okay. Namaste.
Oh. Hello. Namaskar to everyone. Yeah. Fine.
Oh.
Today
Thank you.
Today I could not join because of the office work.
Yeah.
Dr. Jha is about to start.
We are very happy that to see Jha.
Why video is not coming?
You have to enable the video, maybe. Just enable the video.
On your screen, you will see. On your screen, you will see.
Left hand side down.
Left side.
Down. Yeah.
My video is on, but I think I have to share the screen. Yes.
Now you are visible.
Yes. Okay. Thank you. You have to allow me to share my screen from your side.
No, we don't allow sharing screen for security reasons. Anything of presentation you want to give, you have to give to the host and they will use. This is decided because of security of individuals' computers.
So now, no, I send you the PowerPoint.
Oh, right? Wait, it's not started program.
Yeah.
Just wait a minute.
No, but Dr. Said, in the meantime, Dr. Manjul can share his slides with you people.
6 o'clock, yeah. The program is 6 o'clock. Wait for that 1 minute time. Now it starts.
I know, but let him have the slides in his computer.
Okay. No, that will come. Now will come.
Okay.
When presenting only it will come.
Okay.
He has got a copy. We have got a copy. It will come in correct time.
Okay.
Now, it's officially will start. Thank you very much, all our friends. And I would like Dr. Indramani to start this session and introduce the first speaker. Dr. Indramani, please. Dr. Indramani?
The presentation is two parts. One part is
I think he's not able to hear us.
Okay.
Dr. Indramani.
Yeah. Just give a minute. He should be all right. I welcome Professor Gajan Singh is there now.
Good morning.
Good morning. Dr. Indramani was here. Just now he is missing somewhere. I think he's checking the connection. We'll give him a minute.
He is there. He's there, but not video is not on.
So we'll take a couple of minutes more that you can introduce yourself and talk to each other. Another couple of minutes till Dr. Indramani comes.
So I'm here.
Yeah, you're there.
Yes.
Yeah.
Please start introducing. I think we'll start now. You start introducing Dr. Manzul Hazarika and start the program, please.
Professor Singh and friends, greetings from ISC. This is third day of the webinar. And first 2 days, I'm audible?
Yes.
Hello?
Yes.
Okay. And this is third day. Now we see Dr. Yasan Jha and Dr. Mehta.
I was there first day also.
Welcome. So friends, we have two speakers today, Dr. Manzul Hazarika from AIT and A.P. Ramchandran from Coimbatore. So it is a real, good combination because Ramchandran is a practicing farmer, accomplished high-tech farmer, and he's an agricultural engineer, postgraduate in production technology. And before that, Dr. Manzul Hazarika, he is our, well-known agricultural engineer. He did his BTech from Jabalpur and MTech from IIT Kharagpur and PhD in civil engineering from University of Tokyo. And Dr. Hazarika is currently the director of Geoinformatics Center at AIT Bangkok. Professor Singh is here, who has been the architect of AIT Bangkok. I have also personal nostalgia. I was there in 1990 and then again in 1999. So, AIT. He has almost 16 years. He has extensively worked in disaster management issues in more than 20 countries from the Asia Pacific as well as the Caribbean regions. His work includes multi-hazard assessment, emergency mapping and damage assessment, community-based disaster management, and capacity building. He has been actively involved in developing it for with estimating that particularly by floods. While working, he interacted and worked closely with the stakeholders of various levels, including high-level government officials and donor agencies.
No voice.
Is that a problem? Am I?
You go ahead now.
So, yeah. Dr. Hazarika has been closely associated with the ISAE. He was at Pune Convention, and there was an active participation. Before that, he was he is a very good trainer. So he was for 1 month at Rauri and for cast training. And I have feedback that candidates there got a lot of benefits. And today we have Hazarika. He will be speaking on a very important topic related to drone. And now on behalf of ISA and that webinar team, I invite Dr.
Okay.
Yes.
Hello.
Dr. Hazarika, you can continue.
Yeah. So can I share my slides or I cannot?
No, you can tell. You can tell. He will start the slide immediately.
Yeah. Okay. So, okay. Thank you. So, thank you for first of all, thank you, Dr. Indramani and Professor Singh and ISA community in India. And it is my great pleasure to be speaking about drones and its applications. And as Dr. Indramani introduced, I have been working mostly in remote sensing application, remote sensing and GIS. And last 15 years, I have been working on disaster-related issues, mostly using. And in India also, I have recently completed 2 projects in Uttarakhand after there's a big World Bank project on risk assessment and decision support system. And right now we are developing a decision support system, customizing existing one in Uttarakhand for COVID-19, which I'll share with you later, maybe within a few days, some of you. As far as agriculture is concerned, I have been also started working with FAO here in regional office. We have been doing several things with FAO. One is also to assess the crop damage by flood using satellite data and so forth. So that's one of my new area. Back to habitat again in agriculture for a long time. And it has been, and we are started working in several countries right now. Now the topic today, drone and its applications. I am also joined by my colleague Sasanka, he's in my back. He will also talk about a little bit of drone development. We also build drone by ourselves, so he's the man. And so I will, first part I will talk about the basics of drone, and then what are the applications can be done, especially focusing on agriculture. Then I will ask Mr. Sasanka to talk about the drone, how we are building our drones. Okay, next slide.
Very good.
Okay, so there are basically, if you want to acquire data, one of the common platforms is satellite. This is 100 kilometer up. Then we, which is most popular, I would say. Then we have these aeroplanes, like you might be heard about aerial photographs in old days. And also, hello?
Yeah, we can hear you. We can hear you. Go ahead, please.
Then we have the conventional surveying techniques. So these are the mainstream data acquisition platform, but drone has surfaced in very recently, which is in between, say, aeroplane and ground survey. And this has been coming up very strongly in many countries because, next slide, I will explain. Okay, so these are the four platform satellites, which is very extensive coverage and wide spectral capability. It means they have several bands or cameras to take the images. But problem is it is expensive, and relatively if you go for affordable one, which will be maybe 30 centimeter and so, not expensive or even free. But if you go for high resolution, like the drone one, it will be very, very expensive. And it can be taken data weekly or bi-weekly, something like that. Then aircraft, large single flight coverage, also high resolution, 7 centimeter per pixel. Again, wide spectral capabilities. But the cons is also, again, very expensive. Flying a aeroplane is very expensive, and it also a lot of permissions are required, and those an operation susceptible to weather. And on the other hand, last one, if you look at the surveying, which is excellent position accuracy, very high, good resolution, but it is slow, tedious, and labor intensive, and difficult to. And some of the areas which is inaccessible, you cannot do the survey. But drone, which is image acquisition on demand, satellite or aircraft, this you cannot do on demand, but you have to take a plan ahead. But drone, it is with you, you can do acquisition anytime. Very high resolution up to 1 centimeter. No effect of cloud. Satellite has a problem with cloud. Aircraft has a problem with cloud. Cost effective and safe. But limitations is relatively low coverage, and drone regulations can restrict operation. Even in India today, drones are not private sector. Commercially, you cannot fly any drone as per the regulation as of today. So, and also, of course, operation is susceptible to weather, but still you have some windows where we can still fly drone. Next slide. Okay, so in terms of performance, if you look at the horizontal x-axis, price, accuracy, flexibility of location, technological maturity, market maturity, and delivery time. And the y-axis 0 to 10, 10 is the good, and 0 is poor. So if you look at the price-wise, the satellite is, as I said, very expensive. So this, in terms of grading, it is low. A drone is quite almost 10 point. It means it is drone price is almost, I mean, if you have a drone, it is free, basically. Data is free. And then accuracy-wise also drone, very high accuracy in compared to all others. Flexibility of locations, I mean, where you fly and all, so you can, that is also quite flexible enough. Technological maturity, which is still a lot of things are being developed, but market maturity is almost not really, I mean, you can, there's a lot of scope for drone in terms of market. They are projecting very high growth of drone market, and delivery time is also very good. Even if you fly today, some area we sometimes within 2 days, 1 day, 2 days we can do that. Next slide. Okay, so drone saves money, time, and provide quality data. So if you look at the low operation, for example, helicopter or aircraft, which is quite expensive in terms of capital cost as operation cost. Whereas if you go for drone, this is capital investment is very less, and also operation cost is pretty. You don't need a trained pilot like helicopter or airplane. And right side accuracy of, I mean, if you get a job within, if you do for surveying, conventional survey, which might take 2 to 3 weeks, with drone we can do it 1 to 4 days. And below right side you can see 2 images. One is from satellite, left side is drone and right side is satellite. Same area, but you can see drone's image is much better, which is 5 centimeter per pixel. And commercially, the most commercially commercial standard of data is now 30 centimeter. So if you go for 5 centimeter, it's still 6 times higher than high resolution satellite, commercial satellite data. So it's still advantage there. Next slide. Okay, so drone is basically the relatively small size remote control automatic pilotless aircraft. There are different kind of drones. The drones which I am showing you, all the 3 drones, first is multi-rotor. You have several propellers. That's why it's called multi-rotor. It is this, all the 3 drones, multi-rotor, fixed wing, and the hybrid one, all 3 were developed here in our center. We assemble by ourselves. And the first one is a multi-rotor, which can go up to 300 meters, 20 to 30 minutes flying time, and very small area, because you can see so many rotors, so a lot of energy is consumed. So it's only 20, 30 minutes you can fly. The left one is fixed wing. It can go up to 2 kilometers, 90 minutes flying time almost, and it can 5 to 10 square kilometer per flight, and it can go up to 100 kilometer if some kind of long missions you can send that. And the down one is a VTOL, which is vertical landing and takeoff. And this is the new one because you see the left one, I mean the fixed wing need a lot of space to landing. So it's a lot of problems. So we make the multi-rotor and fixed wing together to make it VTOL. It can vertically take off and vertically landing. After vertical takeoff, it can take the round to do the surveying and mapping. And after that, vertically take off. So this particular drone up to 300 meter, 40 minutes, and maybe 1 kilometer square per flight if you fly it in 120 meter height, and range is 70 kilometer. And this particular drone, we when Ismail said, Dr. said, told me yesterday, then we immediately, yesterday we tested this drone, and we had a video, maybe hopefully we can show you today. So that's next slide. Okay, next slide. Okay, so first, one of the most common is surveying and mapping. So for surveying and mapping, mostly we are using this optical camera, RGB, red, green, and blue band cameras, which is very similar to our normal camera, photographic camera. It can be also used. But if you go for very high accuracy, then camera price will be quite expensive camera. You can use also photogrammetric camera, which we call. The right side is LiDAR, which is, this LiDAR is I think 500 gram weight. And this is from Velodyne, American one. And this can be also, people are using in drone. But it has also a lot of other issues, but I think very soon it will be becoming very, very popular. Next slide. Next slide, yeah. Okay. So this is our team. Go up, previous slide.
Previous slide, please.
Previous slide. Yeah. Okay. So this is our team. They're in Colombo, and they fly drone to get this some snapshot of Colombo city a few years back. Next slide. And here you can see all the buildings very detailed. And then if you come for this slide, then you also get the height. So both mapping and getting the height elevation is very much possible. But issue, of course, you have to fly in a certain way that you get the elevation. Particularly, you have to have some overlapping between two images to get the stereo pairs. And that's how this is also the dark green is very high elevation, and the blue is the ground level. Next slide. Okay. So the left side building is maybe Professor Singh might know. This is the Asian Development Bank building in Manila headquarters. So we were asked to demonstrate how drone can be used in ADB project. So we gave a training, then we fly our drone and we get this 3-dimensional building of ADB within maybe 5-6 centimeter accuracy. It's a very good model we developed, and they were quite impressed. Right hand side also you can get the tree heights. I'll explain how it will be useful for us, if particularly something related to agriculture related. Next slide. Okay. So agriculture, use of drone in agriculture, again, we can use the optical camera, the left side. And the right side, these are the multispectral camera, where is like red, blue, green, red edge, infrared, all the cameras are there. It has 5 here, you can see 5 camera. This is very similar to satellite, very similar to satellite. Satellite also have this kind of camera, we call sensors. Next slide. So this is a very simple vegetation index. Basically, when if you look at most of the satellite data, any remote sensing data, this concept is used to know how green our vegetation is or a crop is. So this is called NDVI, Normalized Difference Vegetation Index. So left side, you can say green one. So the incoming sunlight, it is most of the in red channel, I mean red band. In all the energy is absorbed, which for photosynthesis, and in near infrared, all the 50% energy is going out. On the other hand, if it is not green, then you see that there is what is incoming and outgoing is very similar. So left side, if you calculate the NDVI, you can see 0.72, means it's very green, whereas there's no greenness, it's 0.14. So this value from 0 to 1, near 1, 0.9, 0.8, 0.9, or more than 0.8 is very healthy vegetation. That's the basic concept. And we use this particular principle for all the drone mapping related to agriculture. Next slide. Okay, so monitoring large plantation is a very painstaking job and time-consuming task. So drone can provide a high-resolution map to identify anomalies in the images to identify pest attacks. Basically, I was in consultation with some of the tea gardens in Assam. So they said that some of the pests come and within no time it will damage large amount of their tea bush. So normally they have tea garden size or average size is 400 hectare, 400, 500 hectare tea gardens are there. So manually they go and check. So sometimes 500 hectare manually checking will take days. So if some pest attack is there, so it will take quite amount of time to identify. So I think that if we fly a drone, we can very quickly take this, identify this attack, and immediately we send a team to do the spraying. So it will also limit the use of chemicals for pest control, because there are a lot of regulation. They cannot use many chemicals, and also type as well as amount of chemical they have to keep it within the limit. So this is one of the things where I'm working with tea garden in Assam. Next slide. Okay, so also in some cases you can see the invasive species of vegetation. They go to the inside the plantations, and if it is a large plantations, so drones would be very useful. At very short time we can see how what are the area affected, and you can send the teams, because you have all coordinates and location of each of them. Next slide.
Dr. Hazarika, just a small request. You have enough time, but we are all very happy to listen. This so clearly you're explaining. So don't worry about time limit. There is no time limit. Please go ahead. We want to understand. We want lot of engineers, young budding engineers are listening to you on the Facebook. So I request you, please explain slowly. You go explain everything. Thank you very much.
Okay. Thank you, Dr. Said. So use of drone in plantation is coming big way. Because data coming from drones can be integrated GIS to maintain an accurate crop database. As I said, a tea garden has 500 hectares, and some largest tea garden in Assam is around 800 hectares or something like that. So location-specific information of those crops, plantation crops, are very easy using drone. And this database, which could be information about the some location where fertilizers content in the soil, or some of the areas if some bushes are not doing well, some areas are not very healthy. So those are water stress. This can be when you're flying, because you get the coordinates, so you can easily do. And I think this is one of the biggest applications of drone is coming up in Malaysia and Indonesia for oil palm plantation monitoring. Because you see, oil palm is maybe several, how much, maybe 6 meters maybe high. And then it is very difficult, and they have to see they can see from the down, they cannot see the up. So drone is very useful to see the up and see if any problem, any pest problem. And also, you know, this oil palm or tea garden, coffee, these are monocrops. When there is a monocrop, there's a lot of problem with pests and diseases. So that's why I think it's very effective. Next slide. This is again, I just mentioned oil palm plant. You can see from drone, you can see all the left side. You can see all the tea bushes. And also some of the tea, if quality is poor or not productive enough, this kind of image analysis and see the quality tree in terms of as a photograph or as a NDVI also. Then you analyze and you can identify unproductive the plants and replace that. And also some of the coconut tree counting right side. And I was listening to one of the presentations recently. There is a very big typhoon, and they damaged the coconut trees to great extent, and government compensated by each tree. So it is very difficult to know how many trees and where. So, but if you fly a drone, it will be, you can count the trees, damaged trees, and also you can compensate to the farmers. So this is one of the countries they have done. Next slide. Yeah, these are the, again, plant counting, and if there is a gap, you can feel. You see here, say some gap in this location, or here. So the you can those kind of things can be easily done. Otherwise, if you do manually, you have to really go to all the places and see, and it will be very, very time consuming and expensive also. Next slide. Okay, so this is biomass estimation. Drone can be used. You see, one of the problem with biomass estimation, we were working in Nepal Forest Department some time back. We are using satellite data, both optical and microwave satellite data. So when you do, you can know the greenness from optical data, and also some of the information about the wood, the trunk from microwave satellite data. But the problem is when you convert this greenness or the trunk information to actual ground data, accuracy is very, very low, around 0.4, 0.5 R-square coefficient, something like that. So that was a serious problem. Then one part of Nepal, we had some LiDAR data and the height information. So when you bring the height information along with this other greenness information, then your accuracy goes up drastically. So from drone, you get the greenness of the health of the vegetation as well as height. And you have few samples, some samples in the ground. You can do the biomass estimation very, very accurately, and which is very, very important for many industries. And probably recently I had a discussion with a Japanese person. There's a very big company called Marubeni, Japanese company. they have a large eucalyptus plantations in Malaysia, which is, I think, quite 4,000 square kilometer total in the different places of Malaysia. So they are also using drone to look at this biomass estimation. And recently this kind of plantation eucalyptus demand has been increased very high level. The main reason is because of this your e-commerce, this Amazon and others, all the packaging material are coming from, they're using raw material is eucalyptus. So that demand has gone drastically in recent years. So I think in India also now e-commerce is picking up. I think this is one of the area where there is a very big market. Next slide. Okay, so this is one case study my colleagues has done in Thailand with Thailand, one of the Rice Research Institute in Thailand. Professor Singh will know it is Oithya Rice Research Center, which is around 30 kilometers north of AIT. And they have a control plot, 16 control plot. And number 1 is no fertilizer, 2 to 11 is gradual increment, 12 is optimum fertilizer, and 13, 14, 15 is more fertilizer. So this is 10 meter by 5 meter plots where we jointly, with our collaboration with them, they grow the rice and we fly drone every few days to monitor the rice. Next slide. So you can see this is a photo, just image, normal photo from drone, and the plots, which actually in the ground. Next slide. So the images were collected in each phase of rice. Most of you know transplanting, tillering, and pinaculation. These are the rice and rice stages. And from transplanting up to the flowering stage, this is the stage where we regularly every 8 to 10 days we fly the drone and see the greenness index NDVI. If from transplanting up to the flowering stage, if it is consistently green green enough, you can expect that this will give some good yield. And in between, if there is some problem and your greenness has gone and your NDVI, which I talk about, goes down, it means it has some problem. It could be some pest, it could be some water stress, it could be something else. So then it will affect your yield. So this is this particular exercise we used using satellite data. I did a project, a World Bank project in Uttar Pradesh in 2013, and we use satellite data using the same principle. Every 8 days we see the rice status in whole Uttar Pradesh. And beauty is that the moment you take the last reading in the flowering stage, at that point of time, you can predict the yield. You don't have to really wait till it harvested. Because we have satellite, in case of satellite data, every year we have this NDVI data every 10 days. And we know the yield in last, say, this data, satellite data is available from 2001. So 2001 to 2019 data, we have satellite readings every 10 days. We have also production, rice production. So you can make a regression equation. And the moment this 2020 data come, the greenness, immediately you can put your value in the regression and you will get the yield. The idea is that it is maybe not 100% correct, but at least I would say 80% or plus, depending on how much field work you have done. 80 to 90% correct at the before harvesting. And if you know the rice estimation of the country, say India, before harvesting, you know that how much rice is coming, and then you can take a decision how much, whether to import or export. Because at the time of harvesting, you know, then international price are low. But if you wait, then it might go up. And so this is one of the good to the. We try to do the same thing using drone. And next slide. So this is, you see, the right side is our plots, and left side you can see up one, this red boundary. These are the grass, and you can see the signature. They are a little bit white or light color than your rice. So this is an experimental plot, but if you have a large garden, large plantation, so this information could be useful. What are the other weed or other invasive species is coming up? So large scale plantation, it will be very, very useful. And left side down is the actual close photograph of our plots. Next slide. Next slide. Yeah. So this is the basically the both images are, I'd say same. No, go. Oh, okay. Okay. So if you look at this graph, left side upper, there is a, you see this greenness index from transplanting. It is going up, and this is the peak. Then it is going down when rice start ripening. It's becoming golden and it's going down. Next slide. Next slide. Okay. So this is all the 16 plots. We try to plot every 16 plots, and also then because it's a control experiment, different inputs, and we try to see how things are changing in different plots according to inputs. Next slide. Okay. So this is the yield. Down x-axis is again the greenness, and you see greenness is increasing 0.82, 84, 86. At the peak, it was 0.94, 0.92. After that, we got the reading. Then it started ripening and going down, and you can see the yield. Also, we have some yield data from past data. So this is NDVI, and right hand is also NDRE. The left side we are using two channels, red channels and infrared. So I is infrared here, vegetation is infrared, and here right side instead of infrared, we are using red edge. It is in between red and infrared. But we try to see is there any difference, because our camera, that Sequoia camera, that multi-spectral camera, is the same. It has both the camera. That's why we try to use this one. Next slide. Okay, so this is one of the drone we have built by ourselves. So so far I have given a background and some of the applications. So this particular one, I would like to request my colleague Sasanka to explain how he built, and because I think for agriculture engineers it is very important that if we don't go to the new technologies, I think it will be very soon. This space will be occupied by the other electronics engineers or those kind of people. Because my experience in Pune, when we organized the workshop, there 10 startup companies came, which is agriculture. Out of 10, only one person startup CEO is agriculture background. Others are all electronic, computer science, and data, this and that. So I think it is important that we also spend our agriculture engineers fraternity. They should take it very seriously, need to be changed. I mean, put this kind of electronics and things very to the curriculum. And Dr. Syed, he is always advocating this. And I am saying this because none of us here, we are not electronic engineers, none of them. The person who developed, he is a surveyor, but he went to we got some guidance from one Japanese institution. The person who developed in Japan, he's an earthquake guy. So do it yourself, having some idea, a little bit of everything is open source. Everything is freely available. You can buy all parts and you might do it yourself. I think this is a time we should try to do this. So I will ask my colleague Sasanka. So yeah. Yes, he is our staff here, and he is, as I said, basically surveyor from Sri Lanka, and he will be finishing his, he worked how many years?
5 years.
5 years, and in this September, he is going to Netherlands for his master degree in this area. So over to Sasanka.
Yes, thank you, Dr. Manzul. Yeah, sure.
Yeah. Okay.
And good evening, everyone. So,
good evening.
I'm Sasanka, and I'm working in GIC as a researcher. So I'm the guy responsible for building these custom-made drones. So before introducing these drones, so I will tell a story that why we are building this kind of drones. So there is an online platform to process the drone imagery. So they did a survey in 2019 about what are the type of drones people use to be processed in their platform. So in that study, they have found out that around 90% of the drones people use are consumer grade drones. Consumer grade drones are basically like, for example, we can say DJI drones, DJI Phantom series drone or Mavic series drone. So these consumer drones available to the people at low cost. So the most of the processing data in their platform are coming from these drones. So one main reason for people to use the consumer grade drones for surveying. So these drones are not built for surveying, but it can be used. The one main reason is the survey grade drones are really expensive. So if you take an EB, so there is one popular survey grade drone called EB, which can cover a large area and up to very high level of accuracy, and it costs around $25,000 US. But when compared to a consumer grade drone, it just costs around $2,000 US. So people are more likely to use consumer grade drones. The disadvantage of the consumer grade drones is that, of course, it can map, but the accuracy wise and the coverage wise, the most important thing is the coverage. So if you take a consumer grade drone, it can only fly up to 30 minutes. But if you take a survey grade drone, it will cover a large area. It can fly up to 90 minutes or even more, even further. So our idea is to build such kind of survey grade capable drone at low cost. So that was the initiative. So we started building these drones at our center. So far, all the drones we have prepared are under $3,000 US, and still we are achieving the same level of accuracy. So Dr. Hazarika clearly explained that about the sensors we can use, and the task of this drone is to act as a platform. So it takes your sensor up in the air, and drone has to follow a certain path in order to capture your data. So that is the task of this drone. And as Dr. Hazarika explained, so all these parts you can buy online, and the firmware we develop, the base is open source. So based on that, you can develop all the hardware, and also all the firmware are open source. Sorry. All right. So this slide, it particularly show fixed wing drone we developed for long range mapping. So we call it FX79 Berunda. So it is also under $2,000 US.
Next slide. Yeah.
Okay, so drone hardware, if you take the drone hardware, it has several parts. So first one is the drone itself, which consists of the fuselage and propulsion. So propulsion will be a motor. If you take a fixed wing drone, there will be a thrust from 1 or 2 motors to get the velocity. And if you take a multi-rotor, the thrust will be directly given upward. And this drone's control surface and the thrust are controlled by an autopilot. So for our drones, we are using an autopilot system called Pixhawk. It is one of reliable open source projects. So the hardware itself and the firmware running on, it's called ArduPilot, and both are open source. So for these sensors, we can integrate either RGB sensors. So right now we are using an RGB sensor, or we can integrate a multispectral camera. And all the data coming from the drone will be the geotag images or geotag data. So that will be processed in specific software. So we call it photogrammetric software, and we can get the products.
Next slide.
Yeah. This slide is about the FX79 Berunda. So you can see it in the background. So it's hand launched by one of my colleagues. And these are the specification of this drone. So if we compare this drone, the drone's price with a commercially available survey grade drone. So commercially available survey grade drone, it has around, the price is around 25,000 if you go for an SenseFlight EV. But this drone also has the same functionality and acceptable level of accuracy, but it lies in the range of a consumer grade drone. So it is just, we can build it around $3,000 US, and it has quite a long range as well as quite good flying time. So when it comes to surveying this, the range of the drone and the endurance, it matters because it defines how much area we can cover in a single flight. So overall, it matters to the efficiency of our project. Next slide. And this is the overview of the system inside the FX79, that fixed wing drone. So you can see in the middle, this is the flight controller. So this is the brain of the drone. So this controls everything. And here we have the camera. So this is a very high resolution Sony camera. And this is timely triggered by the Pixhawk. And we are using a positioning system here. So
GPS.
GPS system. And batteries here. And this is motor control unit. We call it ESC. And the other electronics are beside this part. Actually, there are 2 components here. So that will be our transmitter and the telemetry transmitter and the video transmitter. So all these parts these are the parts which are inside the fixed wing drone. Yeah.
Next.
Next slide. Okay, so this is the overall figure of how the things are connected. So these components are inside the drone. So on the ground, we have our ground control station. So it is basically a receiver. So here all the drone's telemetry data is transmitted by a radio signal, and we can receive that signal using a receiver, and we can run we run our ground control station software here, and the control of the drone is done manually by a remote controller, but when we are doing the surveying, all the operation will be autonomous. So this is just in case of emergency as well as for launching. So after launching, we switch it to the autopilot. So the drone's autopilot system will take care of collecting the data as well as flying the drone. Next slide. So this is the coverage that we can get using our fixed wing drone. So initially we tested with 2 different camera systems. So this is the very high resolution camera, and this G2 Pro is a wide angle camera. So the amount of coverage we can get from one image is high. So you can see here, so this line corresponding to the GitHub G2 camera, and this is for the Sony RX100 camera. So this is very high resolution camera. If we are dealing with a project which requires to make rapid maps, then we can go with this kind of imaging system. Next slide. So Dr. Hazarika already mentioned that in order to make a map using drone, we cannot get the data randomly. There is a specific way. So this figure explains that a specific way. So we call it a flight plan. So drone has to fly in a way that it captures overlapping data. So in this figure, it is explained if you take one image, so next consecutive image has to overlap some of the area of the one image. As a rule of thumb, it will be 70%. As well as the next line also has to overlap. So this is essential if you are doing mapping with a drone. So the drone we have made are integrated with the flight planning option also. So we can do the flight planning using our ground control station and upload it to the drone. So with the flick of a switch, we can tell the drone to execute that mission autonomously. Next slide. And this is the Mapp product. This is the Asian Institute of Technology, the institute we are based on. So this is 1 square kilometer. The total area is around 1 square kilometer. So this is the map we have created using our fixed wing drone. So if we compare it with a traditional or consumer grade drone, normally a DJI Phantom, it will take around 6 flights. But the drone we have built here, it only takes just 1 flight, and within 1 hour, the whole area can be mapped. Next slide, please. And this is the elevation model, so digital surface model, created using the images we captured. Next slide, please. And here is a quick comparison about the features of the custom-made drone as well as the compared to the other drones. So the FX79, the drone.
The price here, depending on also the camera and many other things.
Yeah.
So it is kind of, you can always give a range of the price.
Yeah, sure. So I mean, initially we need investment also, capital investment. If we take only the parts, it can be around $3,000 to $2,000. But if we incorporate all the other factors, such as the amount of other equipments required, so we need some electronic workstations to build this drone. So if we incorporate that cost also, we can say it is around, the cost will be around $4,000 US. And still you can see that these last 4 drones, these are survey grade drones. So the average price of the survey grade drone, we can see it lies around $20,000 US. But if you take a consumer drone, it ranges around $1,500 US. So the drone we build here, it only costs, when we compared it with the survey grade drone, it costs a fraction. And if you go for the accuracy, so you can see that survey grade drones provide very high level of accuracy. So EBX, so this is one of the most advanced survey grade drone made by SenseFlight, and it has around 1.5 centimeter accuracy. The accuracy of the drone we built here is around 34 centimeters, less accurate than the commercially available survey grade drones, but application decides the accuracy. Sometimes we need this kind of 1.5 centimeter accuracy, so then we have to go with these kind of survey grade solutions. But most of the general case scenarios, the 34 centimeter accuracy is enough. So if you take the agricultural monitoring, for example, we may not need 1 or 2 centimeter accuracy. This level of accuracy might be enough for our analysis.
Also, just one point here is because we are also using not very high grade camera. So if you buy very high quality camera photogrammetry, then it will improve further.
Yeah.
So this kind of, and also positioning system, if you go for the very cheap one, maybe you can get $100. If you go for the very high accuracy, which will cost you $1,000 or $1,500. So it can be improved, but you have to invest more. Yeah.
Next slide.
Next
please.
slide.
And this figure is important when we take it for surveying or any mapping project, because this indicates how much the drone can cover within a single flight. So you can see that if you fly around 120 meters, our drone, it can cover around 200 hectares. So quite a large number compared to the consumer drones, and it lies in between consumer drones and the commercial survey grade drones. So the next figure, it explains the one of the main difficulty in these custom made drones. So operating a commercially available survey grade solution is relatively easy, but when we go for a DIY solution with open source hardware and open source firmware, the operation complexity becomes very high, so it becomes sophisticated. So you need specific knowledge to operate this kind of drone safely. So that is one of the limitation. Next slide, please.
So, sir, I think the video I did not send to you because it's very big size.
Okay.
I was thinking that I will run from here. So
since you cannot run.
And since you're not doing, so I think we will not.
I can give you the host. You have used Zoom webinar. Have you used before?
Zoom, yeah, I have. We are using Zoom.
Zoom webinar you have used. Okay. Now I would request you will get the screen sharing everything. Setu, can you make him host, please? Setu, can you make?
Yeah.
Yeah. Now you are the host. Now you can share your screen and you can play the video.
Yes. Can you see my?
Yes. Yes, I can see. You go ahead. Full screen. You can make it if you want. Yes, you can run.
Okay. So this is the one which we develop, as you have explained just now. So this is test flight we did. So flight planning we do using this is Ardo Pilot, is open source, completely open source, and you do these are waypoints which way it will move, it will go. So before flying, you make this plan and you take it off. Okay, so it's gone, and sorry, so this is some camera. Sorry, okay. This is some camera in the front we just put. This is not the photogram for photograph, just to see where it is. So now you see after initial takeoff, it will now follow the path which we have given. This is in AIT football ground. We are so now landing. So one of the problem with this drone is it needs huge long runway for landing. So it was a problem. So we did something. Just you look at what we have done. You see, we put a parachute up there and it's vertically landing. Okay, so this is what we have done. Okay, so then also this is fixed wing, and then this one we develop. We are in the lab, so it is hybrid. You see these two lines here. There is a propeller. So this is as a quadcopter. I mean like a multicopter, and this is plane. So going up, we can use this one. So yesterday we test flight just from our lab to just to show you today. It's going up. So once it attain the height, then we stop these 4 propellers. Then we start the back propeller. Now it's moving forward. Very speed. Yeah, it's somewhere here, I think. I can call it a little bit. Okay. Yeah, sure. Not in the tree, right? Now it's coming. So it's a little bit noisy, I think, because of so many propellers. 4 propellers are there. Yeah. Our cameraman was not good, I think. So not professional, maybe. Okay, landed. Okay. That's it. Thank you very much. Any questions and comments?
Oh, wait. You can. Thank you very much. We'll talk. You stop sharing your screen first so that I can come to the next. You stop sharing first.
Right. Just
stop sharing.
What this
in your screen? Only stop sharing. You have to click. Or okay, I will. Yeah. Yes. Okay, I have done that. Now I will explain you. question and answer. Those who are panelists, we will start your video on, so you can raise your hand if you have questions. Those who are attendees who cannot speak, the mic is broken. Sorry, my mic is blocked. So they can, there's a button there they can see, raise your hand. So we will see it, then we call for the people to speak. First, give me a second to transfer it to the correct host.
Professor Singh is raising hand.
Yes. Let me first thank him, then I will give to Dr. Singh. I think, first of all, I want to thank Sasanka. You done an excellent job coming on today for all of us and telling the exact, like the guy who has done the job. So it is a very, I have to thank you very much for sparing your time. And Manzul is something, yesterday I told him, and I told him I owe you something. He's a guy, great guy. He told, come on, it's my duty to do it. I mean, that type of person like Manzul, who is very down-to-earth person. And I really appreciate, we all appreciate how much time you've taken to explain us point by point about what type of drones, because this will be useful, especially for the engineers who are coming out, agricultural engineers, to understand the basic stuff to come. And that you've done a wonderful job. I think, again, I all will thank you. I give the time, but I think I'll ask Dr. Gajan Singh to first.
Yes, first of all, thank you, Manjul, for giving this excellent seminar. I think for information, you know, the Manjul, Sayyad and Ganos Bora are working as a team to help Rahuri to make use of this kind of technology. And I'm very proud that this team, AIT team, I should say, working hard. Now, I want Dr. Mehta, C.R. Mehta and Indramani to think what kind of investment is required. They should consult with Manjul because they have a very small team. The whole AIT faculty is smaller than CIA Bhopal, okay? And we talk about AIT so many times. So I think
we are online. We are online. We are online in Facebook. Yes, we are online on Facebook.
So please think about it and you consult Manjul. He has a very small team, okay? It'll be a little, I think, embarrassing to tell how few people they are and putting these big things together, okay? So this is my suggestion that CIA Bhopal, being our lead institute, should be thinking of putting drones together for various uses in agricultural research, okay?
Dr. Sia Mehta, please. Dr. Sia Mehta.
Yeah, good evening, everyone. So, first of all, I thank Manzul Hazarika for very good and informative presentations. And I also thank Sasanka for developing such drones and showing their applications. And as suggested by Professor Gajendra Singh, we have already planned to work in this area. We have initiated work in at some places in country. Even some centers of ACRIP on FIM has already started working in this area. But certainly, he has provided information related to most of the area in which the drones can be applied. Even we are planning to assess the yield of fruit trees also. So drones can be applied there. And he has also shown application for counting of drones for tree plantations and other. So certainly we may like to even coordinate with them and we may like to take their help in our work. Our team is really young and they like to work in this area and we are motivating them. Even our council is also right now finalizing the policy for operation of drones, and that DDG Engineering is chairman of that committee and Dr. Indramani is member secretary of that committee, and soon we will be in a position to finalize the policies for operation of drones.
I think you should be fabricating them, assemble them, fabricate in CIA.
Yes, sir. Thank you.
Yes, I think that's excellent suggestion because people try to import. That was one of the reasons why I trying to make this webinar is to promote our local guys can make it. And there is somebody trying in Pune. I think we should try. I think agricultural institutes can do it. 100%. There's enough people we have skill. Now come to the next one. I think many questions are there. There is a doubt, so I will tell you the panelists. The panelists can see right hand side. There is a raise hand. If your video is off, no problem. You will see a raise hand, a button, a tab is there. bottommost right in the participants. When you see the panelist participant list, you click on the participants. Otherwise, you will see a list coming there, and down you will see raise hand. You press the raise hand, then I can see you that you raise the hand, then I can tell to roll. Now, first I would like Dr. Narendra Shah has raised a hand. Narendra Shah, can you speak, please?
Yeah. Can you hear me? Am I audible?
Yeah, all of us can hear you. I can see it. I will tell us.
Right. Yeah. So this is actually a question to Dr. Manjul, that the efficacy of monitoring, for example, the biomass systems, is it scale dependent? What I'm trying to say is, let's say in the rice agronomy experiment, when you had the small 16 different plots, and you showed that your accuracy was something close to some 80%, 90%. But let's say if you take a large horticultural garden, let's say Mossambi garden or orange garden, let me put it that way, so will the efficacy or the accuracy of sort of estimation of, let's say, for example, the fruit product estimation in a horticultural garden, would that come down with a scale?
I think our work is, so far we are confine ourselves in rice, in experimental as well as a large area, and which is, as I have shown to you, it is based on the greenness of the crop within that growing period of, say, let's say 3 months. Now, if you look at the horticultural crop, it will be perennial green probably throughout. So if we can establish some relationship between the greenness and or biomass of the tree with the productivity, I think that is possible. Like if you can find some empirical relationship or something like that. But other than that, the most in the horticultural plantation or tea or coffee plantations, our idea is to, these are very large scale gardens, and monitoring that if some pest attack is there or some water stress is there, manually large garden, and you cannot have a car or something inside the garden. You have to go by bicycle or walking, which takes a lot of time. So I think that kind of thing, it will be very, very useful. And currently we are submitting a World Bank proposal in Vietnam to fly drone for monitoring coffee. So I don't know if it is come up. If we win, then maybe we'll be doing some survey in Vietnam in next 2 months' time. Yeah, thank you.
Thank you. Thank you. Next question we have from Dr. Gandhi Murthy, please.
Thank you so much, Dr. Syed. Thank you so much again, Dr. Hazarika. So I had a very specific technical question, in the sense that when you showed the 16 plots for the different rice varieties, they all had different responses in terms of the NDVI, basically. So my question was, now that for a large country like India, we know that we'll be having different varieties of rice in different small scale fields. Is it possible to estimate the yield, because the yield is dependent on those NDVI values and that correlations there, and it is varietal, specific variety dependent? Is it possible to estimate the yields for different varieties? Or basically my further question is it possible to extract the varietal or the varieties information from those NDVI values?
Yeah, thank you.
Thank you. So actually, honestly speaking, we have successfully done this one, as I mentioned, to Uttar Pradesh, all Uttar Pradesh, we did using satellite data. And we are trying to replicate the same in a very small plots. But if you look at the whole, the framework, my idea is that we regularly monitor the rice, say, one state or few states, because we are getting free satellite data, 250 meter resolution, cloud free every 8 days. Okay, so this satellite data we use, and we get this NDVI. And if there is some pockets we see some problem, NDVI, there we can fly drone to see exactly what is happening in those areas. Not really yield estimation, we can use that drone. But having said that, your earlier question about the different variety of rice and other things, yes, I agree. what we have found in Uttar Pradesh is NDVI in two different locations, same NDVI, but different yield. Reason is because of their rice variety is different, their environmental condition is different, soil is different. So the best way what we did is we make yield model for different location, different yield model, and then we estimate the rice yield. Then we combine together. So that will, although as I said, NDVI is the same, but the yield is different. So we can do one thing. One of the problem is to get the for our satellite data 250 meter by 250 meter cell, we can produce the yield, but because we are making a regression equation, so the minimum size of the yield in the some sub-district level yield, if we can get, then we can develop several yield models depending on the location or local knowledge. Then I think that will be much more better. But still, I can share the results with Uttar Pradesh. It's quite promising, I would say.
Thank you. We'll take the next question. We have 2-3 questions. I'll allow another 2 questions because the next speaker ready. So I'll, can you please enable Digvijay Wakhare to speak, please? Setu? Mr. Digvijay Wakhare, you can speak now. We can hear. Mr. Digvijay?
Hello, sir. Could you hear me?
Yeah, I can hear. Please tell the question.
Good evening, all. Sir, I am a BTech Agri second year student.
Okay.
I would likely request you or ask you that what are the criteria or what are the experiments undertaken for drone mapping for which we are interested in studying, and what are the opportunities for now during a graduation level?
Thank you. First of all, I'll answer instead of Hazarika. I think you're second year BTech. I think there's a long way to go. Now, Dr. Hazarika, please.
I think, see, I mean, only thing what I can do is that when I was in Pune last 2-3 times, there is a very big drone company in Pune. It's called IAM. And our World Bank project, they purchase drones from them. And I visited their factory, in fact. It's a very large factory. A lot of drones are being produced. But as I said, in India, these drones are not allowed to operate commercially. They are selling the drones to defense sector, Indian military. And when they demonstrate their drones, like they have developed some spraying drones, okay? And then I asked about them, how you are using for how much to spray for different crops and depending on the height of the crops or other parameters, how you are doing it. He said that no, we don't have any idea about this. We are just putting the nozzles and we are flying. So they need some knowledgeable person.
Okay.
So this computer science in electronics, they can make the system, but they don't know about the rate and how about the how they can apply. So they say to me that they are looking for good agricultural engineer to help them, and they are willing to take them in their company, but provided our engineers should have this kind of knowledge or experience. I think if this kind of curriculum within the agricultural engineering, or I think market is very willing, they will take us very easily. That's why I'm very much confident about that.
Thank you. Thank you.
Sorry to interrupt you, sir.
No, please. Because I think the time is over, because we already next speaker is there. We have time you to keep, and you all know how to be get connected with Dr. Manzul Hazarika. Any questions, or to ISA directly you can contact. We'll again arrange certain one again the program. Now we have to go to the second speaker. Now I would like Dr. Indramani. You want to say something now?
Yeah, actually, very briefly, I want to intervene that this drone project, basically there is a committee from Government of India side, because Dr. Hazarika is mentioning many times about regulations. So there's no regulation as such. We can't fly drone. So for agriculture purpose. So Government of India made a committee under Dr. Alagu Sundaram, and this concern was taken into account. We contacted some manufacturers also who are in the drone manufacturing line, and a team was made which included entomologist, pathologist, and agronomist and engineers, and we conducted experiments in some part of Haryana at some locations for small crop like paddy, then going to sugarcane, and finally fruit trees. And we have come out with some data. We prepared the report. Report has been submitted and presented, and very soon we will have this regulation for drone application in agriculture. This one part I wanted to add, and Dr. Alagu Sundaram Sahab is chairman. I'm convener of the committee, and all these people are there. So this one part will be taken care of. Then ICR Agriculture and Engineering Division, they sanctioned some project on drone and one at IE, and so we have we have started work on that and processing as suggested. I was discussing with my team members who are here on the webinar, and we will be having definitely all these applications which Dr. Hazarika has mentioned here. We will try to take it up in collaboration with the CIAE and other ag engineering institutions. And I'm really very much encouraged that we will be having this drone technology for different applications soon in India, and we will collaborate with industry. Thank you.